This is Mrs. Zappia with Lesson 3 from Module 3, Writing Products as Sums and Sums as Products. Student outcomes from this lesson. Students use an area and rectangular array models and the distributive property to write products as sums and sums as products. Students use the fact that the opposite of a number is the same as multiplying by -1 to write the opposite of a sum in standard form. Students recognize that rewriting an expression in a different form can shed light on the problem and how the quantities in it are related. Pause the video and copy the essential question. How do you expand an expression to write a product as a sum? We'll do the opening exercise, but you don't need to write it in your notes. Solve the problem using a tape diagram. A sum of money was shared between George and Brian in a ratio of 3 to 4. The sum of the money was $56. How much did George get? We'll put George here and Brian below. And we know the ratio is 3 to 4. So we'll use a tape diagram showing that George has 3 units of money. And Brian has 4 units of money. Together, they have a sum of $56. And that is 7 units of money represented $56. To find the amount of money in 1 unit, divide by 7 units. So each unit has $8. Then how much does George have? George has 3 units of $8, which is $24. A key term in this unit is the distributive property. The distributive property of multiplication over addition says that you can multiply A times the quantity B plus C. And you will get A times C plus A times B plus A times C. This is the distributive property. This is written as a product, and on the right, this is written as a sum. Example 1. Represent using tape diagrams. Represent 3 plus 2 using a tape diagram. Representing the 3, we'll have 3 boxes, and representing the 2, we'll have 2 more boxes. So this is the sum of 3 plus 2. Next, represent x plus 2 using a tape diagram. Now we don't know how big the box is for x, so we'll just pick a random length. We'll say that this is representing x, and then we will use 2 more, and this represents x plus 2. Next, draw a rectangular array for 3 times the quantity 3 plus 2. This is the array for 3 plus 2. And we want to draw a rectangular array for 3 times that. So we'll have 3 rows of 3 plus 2. That's the first row of 3 plus 2, and we need 3 rows of that. So we continue drawing. And this is the rectangular array that represents 3 times the quantity 3 plus 2. The first 3, that is the length of the box. And then the width of the box, this is the 3, and this is the 2. And that is the width of the box. Next, draw a rectangular array for 3 times the quantity x plus 2. We drew the length of x about that length, and then plus 2 more, that is x plus 2. And we want 3 rows of that. So that is the rectangular array for 3 times the quantity x plus 2. Determine the area of the shaded region. The shaded region is 3 times x, and that is 3x. Next, determine the area of the green shaded region, and that is 3 times 2. 3 times 2 is 6. So the area of the entire unit is 3x plus 6. We started out with the expression 3 times the quantity x plus 2, and we multiplied 3 times x, which is 3x, and we multiplied 3 times 2, which is 6. And so we have equivalent expressions. 3 times the quantity x plus 2 is equivalent to 3x plus 6. On the left, this is considered the product. On the right, this is considered the sum. Often the directions will say, use the distributive property to write the product as a sum. We'll skip exercise 1, and we're going to go down to example 2. Draw a tape diagram to represent each expression. Our first expression, let's label these A, B, C, and D. Our first expression, x plus y. So we need a box for x and a box for y. Now y should be a different length than x, so we'll make it a little bit longer. So that is representing x plus y. And we need another group of x plus y. And we need a third group of x plus y. Next, draw a tape diagram to represent x plus x plus x plus y plus y plus y. So we'll have x plus x plus x plus y plus y plus y. X plus x plus x plus y plus y plus y. C, 3x plus 3y. Now 3x is one term. And here above we see that 3x is this length, so we want this rectangle to be the same as 3x. And we want 3y. We see above that 3y is this length, so we want 3y below to be the same length. So this is 3x plus 3y. Next, 3 times the quantity x plus y. X is this length, and y is this length. So we want 3 groups of that, so we need 3 rows. And that's 3 times the quantity x plus y. Notice that all of these are equivalent expressions. X is this length, and here is the 3x, here is the 3x, here is the 3x, and here are the 3x, and all of those represent the same amount. And then each y section, we have y, y, and y, and then here you have 3y, and you can see that they are the equivalent amount. And then 3y is also the equivalent amount. So y plus y is equivalent to 3y. And then also here, this 3y is the same amount. So A, B, C, and D are all equivalent expressions. Part B, this is in expanded form. Part A is also in expanded form. C is considered standard form because like terms are gathered. Example 3. Find an equivalent expression by modeling within a rectangular array and applying the distributive property to the expression 5 times the quantity 8x plus 3. 5 is going to be the length of our box, and 8x plus 3 is going to be the width of our box. For the 8x, remember that x was about this long, and we're going to use 8 of those. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that is our 8x. And then 3 more units. 1, 2, 3, and that is representing the 3. So that is our 8x plus 3. And then we want 5 rows of that. So that's 1, 2, 3, 4, 5. 5 rows. So this is our rectangular array for 5 times the quantity 8x plus 3. Now let's apply the distributive property to that expression. 5 times the quantity 8x plus 3. Applying the distributive property, we want 5 groups of 8x. So the 5 groups of 8x would be here. Five groups of 8x, and that gives us 40x. Then we also want 5 groups of 3. And our 5 groups of 3 are here. And 5 groups of 3 is 15. So 8x plus 3 is equivalent to 5 times 8x plus 5 times 3, which is 40x plus 15. Now, these cannot be combined because they are unlike terms. So to recap, we have 5 times the quantity, 8x plus 3. Using the distributive property, it is equivalent to 40x plus 15. This is considered the sum, and this is the area inside the array. And this is considered the product. And the product is the length times the width. Exercise 2. For parts A and B, draw an array for each expression and apply the distributive property to expand each expression. Substitute the given numerical value to demonstrate equivalency. Pause the video and complete A. Then resume the video to check your answer. 2 times the quantity x plus 1 is equivalent to 2x plus 2. Now, substitute the 5 to determine equivalency, or to prove it. So what we want to do is we want to replace each x with the value of 5. On the left, 2 times the quantity 5 plus 1. On the right, 2 times the quantity 5 plus 2. 2 times 6 is 12, and 10 plus 2 is also 12. So we have proven the equality of our two expressions. 2 times the quantity x plus 1 is equivalent to 2x plus 2. For parts C and D, apply the distributive property. Substitute the given numerical values to demonstrate equivalency. So we're going to do problem C. Rewrite the problem 3 times the quantity for f minus 1. And in this one, you'll notice that this is subtraction and not addition. We're still going to distribute in the same way, multiplying the outside term by both of the inside terms. So I'll rewrite that 3 times the quantity for f minus 1. Multiply by both terms. 3 times 4f minus 3 times 1. 3 times 4f is 12f, and 3 times 1 is 3. Now, demonstrate equivalency by substituting f equals 2. In our original expression, 3 times the quantity, 4 times 2 minus 1. So I've replaced the f with 2. Inside your expression, 4 times 2 is 8. 8 minus 1 is 7, and 3 times 7 is 21. On the right, replace the f with 2. 12 times 2 minus 3. 12 times 2 is 24. 24 minus 3 is 21. Since the expressions evaluate to the same value, we have proven that our expressions are equivalent. 3 times the quantity for f minus 1 is equivalent to 12f minus 3. Example 4. rewrite the expression. The quantity 6x plus 15 divided by 3. This should have a parenthesis on the right side. So go ahead and recopy the problem. 6x plus 15 divided by 3. Now, in order to use the distributive property of multiplication over addition, it needs to be multiplication. And notice that this is division. So we need to rewrite this. Remember that division is the same as multiplying by the reciprocal. So we have 6x plus 15, and instead of dividing by 3, we're going to multiply by the reciprocal of 3, which is 1/3. Now I'm going to rewrite that with the 1/3 in the front. 1/3 times the quantity 6x plus 15. Now I'm going to distribute the 1/3 to both terms. 1/3 times 6x plus 1/3 times 15. 1/3 of 6x is 2x, and 1/3 of 15 is 5. These are unlike terms, so they cannot be combined. So your expression is 2x plus 5. To scaffold, to find 1/3 of 6x, remember that 6x would look like this. 1, 2, 3, 4, 5, 6. And we want 1/3 of that, so we're breaking this into 3 equal groups. So there's 1 group, 2 groups, and 3 groups. So 1/3 of 6x is 2x. Exercise 3. Rewrite the expression as a sum. Pause the video and solve this problem, then resume the video to check your answer. Notice in your answer that 1b plus 6 is equivalent to b plus 6. Pause the video and try the next problem, then resume it to check your answer. Our final answer is 5r minus 2. So even though this was subtraction, the distributive property works in the same way. Example 5. Expand the expression. Copy the problem 4 times the quantity x plus y plus z. Distribute the 4 to all 3 terms. That's 4 times the quantity of x plus 4 times the quantity y plus 4 times the quantity z. And so 4x plus 4y plus 4z. This is the sum, and this is the product. Exercise 4. Expand the expression from a product to a sum by removing the grouping symbols and using an array area model and the repeated use of the distributive property. 3 times the quantity x plus 2y plus 5z. We'll use the distributive property. 3 times the quantity x plus 3 times 2y plus 3 times 5z. Simplify. 3 times x is 3x. 3 times 2y is 6y. 3 times 5z is 15z. These are unlike terms, so they cannot be combined. Also, it says to use an area model. So we want 3 groups of x plus 2y plus 5z. So x would look like this, and then 2y would look like that, and 5z. Now we don't know the length of z, so we'll just make it a small box. So that would be 1z, 2, 3, 4, 5. This represents x, this represents 2y, and this represents 5z. And we want 3 groups of that. So we have 1 group, 2 groups, 3 groups. So our array would look like this. 3 groups times the quantity x plus 2y plus 5z. This portion would be 3x. This portion would be 2y. And the last portion would be 5z. So we have 3x the middle portion here, this would be 6y. Drawing these arrays can help us get that part correct. And here, this is 15z. And that's why it's a good idea to draw those lines. So we have 3x plus 6y plus 15z. Example 6. A square fountain area with a side length of s feet is bordered by a single row of tiles as shown below. So this is s feet. And we know that this represents 1 square foot. Express the total number of tiles needed in s 3 different ways. So we'll do that below, and we'll draw our fountain. And we know that the length of this is s. And we know that the length of this section is 1. The first way that we'll divide up the fountain will look like this. This will represent s plus 1. And then this will represent s plus 1. And this will represent s plus 1. And finally, this is representing s plus 1. So I'll color one of those in so that we can see it a little bit better. This represents s plus 1. This represents s plus 1, s plus 1, and s plus 1. So our first expression will be s plus 1 plus s plus 1 plus s plus 1 plus s plus 1. Another way that we can write that is 4 times the quantity, s plus 1. Another way that we can write it, let's draw another fountain. And this time we're going to label according to s. So we know that this section is the length of s. This is the length of s. This is the length of s. And this is the length of s. So we have s plus s plus s plus s. Plus 1 plus 1 plus 1 plus 1. So here we have 3 different expressions to calculate the total area. In this lesson, you have learned to use the distributive property and the rectangular arrays to write products as sums.